Imagine for a moment that everything you know, your home, your family, your entire world, is nothing more than a microscopic grain of dust floating in an unimaginably vast ocean of darkness. That tiny dust particle is Earth. Earth feels enormous to us. We have towering mountain ranges like the Himalayas, oceans deeper than the height of Mount Everest, deserts that stretch farther than the eye can see, and cities glowing like constellations from space. Every human being who has ever lived, dreamed, loved, fought, or created, has done so on this one fragile sphere. Earth's diameter is 12,742 kilometers, a number that feels gigantic compared to human scale. But in the cosmic scale, it is almost nothing. If you placed Earth in your hand as a tiny grain of sand, barely visible, the moon would be no larger than a small marble orbiting around it. And that marble, the moon, already feels huge when you look at it in the night sky. But this comparison is only the beginning of how small Earth really is. Because now, we look at our star, Sun comparison to Earth. The Sun is the blazing heart of our solar system, a titanic sphere of nuclear fire. Every second, it releases more energy than all the nuclear bombs ever built by humans multiplied by billions. Now let's compare. If Earth is a tiny pepper seed, the Sun becomes a massive beach ball next to it. You could line up 109 Earths across the Sun's width. And 1.3 million Earths would fit inside its volume. Think about that. Earth, with all its mountains, oceans and cities, is so small that over 1 million of them could disappear inside the Sun without leaving a trace. Yet here's the shocking part. The Sun is not even a large star. It is average, normal, ordinary, and the next star we will meet begins to show just how tiny our Sun truly is. Sirius A compared to the Sun. Leaving the Sun behind, we now approach a star that shows us what bigger truly means, Sirius A. It is the brightest star in our night sky, not because it's the closest, but because it is genuinely more powerful. Let's compare. If the Sun were a football, Sirius A would be a glowing basketball beside it. Sirius A is 1.7 times wider than the Sun, 2.0 times more massive, 25 times brighter. This means Sirius A does not simply shine. It dominates its region of space with a fierce white-blue radiance. If our Sun's light gently warms our solar system, Sirius A's light is like a white-hot blowtorch in comparison. If Earth orbited Sirius A at our current distance, our oceans would instantly boil, our atmosphere would burn away, and the planet would not last even a moment. And yet, in the grand cosmic scale, Sirius A, which already makes our Sun look small, is still far from the true giants that await us. Because next comes a star even larger and brighter. Vega compared to Sirius A. If Sirius A is a glowing basketball, Vega is a brilliant, white-hot volleyball, even larger and more intense. Compared to Sirius A, Vega is 2.5 times larger than the Sun, while Sirius A is 1.7. Vega shines 40 times brighter than the Sun, while Sirius A shines 25 times brighter. Vega is hotter, whiter, and more energetic. To imagine this, if Sirius A were a white spotlight, Vega would be a miniature supernova lamp, flooding entire regions of space with high-energy radiation. If Sirius A makes the Sun look modest, then Vega makes Sirius A look like a dim light bulb in a warehouse full of floodlights. For centuries, Vega was used as the standard brightness star, because it is exceptionally stable and bright. Its light cuts through the darkness of space with a sharp, icy brilliance. But as bright as Vega is, the universe is only warming up. Because the next star is even bigger, truly a step into the realm of giants. Pollux compared to Vega. Now we approach Pollux, a giant star swollen with age, burning with a steady orange glow. Compared to Vega, Vega is 2.5 times the Sun's size. Pollux is 10 times the Sun's size. This means, if Vega is a volleyball, Pollux is a massive orange fitness ball towering over it. Pollux is not as hot or white as Vega, but it is much larger and physically bulkier. It is a star that has inflated like a balloon after running low on hydrogen. Imagine the Sun as an apple, Vega as a melon, and Pollux as a huge pumpkin overshadowing both. If Earth orbited where Pollux stands, its immense radius would stretch out almost to the distance of Mercury's orbit. Yet Pollux, enormous by our standards, is still tiny compared to the next star on our voyage. Because now, the giants begin to show their true sizes. Arcturus compared to Pollux. If Pollux is a giant, Arcturus is a supergiant among giants, blazing with a deep orange brilliance. Compared to Pollux, Pollux is 10 times the size of the Sun. Arcturus is 26 times the Sun's size. That makes Arcturus over 2.5 times wider than Pollux. So if Pollux is a pumpkin, Arcturus is a gigantic glowing balloon the size of a small house. Imagine placing both stars side by side. Pollux would look huge next to the Sun. But next to Arcturus, it would look like a toy. Arcturus is so luminous that if it replaced the Sun, Mercury, Venus, Earth, and Mars would all be inside it. The heat would erase every planet in the inner solar system instantly. And yet, even Arcturus is merely a stepping stone. Because what comes next makes even Arcturus look small. Aldebaran compared to Arcturus. Leaving Arcturus behind, we now approach a star that glows like molten copper across the night sky, Aldebaran, the burning red eye of the constellation Taurus. Comparison time. Pollux equals 10 times the Sun. Arcturus equals 26 times the Sun. Aldebaran equals 44 times the Sun. If Arcturus is a house-sized balloon, Aldebaran is a hot air balloon the size of a city building beside it. Place Arcturus and Aldebaran next to each other and Arcturus, once massive, suddenly looks modest. Aldebaran is so large that Mercury, Venus, Earth, and Mars would all fit inside it. Its surface temperature is cooler, giving it a deep red-orange glow. It shines over 400 times brighter than the Sun. If the Sun were a small kitchen stove flame, Aldebaran would be a towering wall of fire, stretching wider than imagination. And still, this titan is not even close to the giants that lie ahead. Rigel compared to Aldebaran. Now observe a truly frightening star, Rigel, the brilliant blue supergiant in Orion. Compared to Aldebaran, Aldebaran equals 44 times the Sun. Rigel equals 78 times the Sun. Rigel shines with the power of 120,000 suns. This is not just bigger, it is another category of existence. If Aldebaran is a city-sized hot air balloon, Rigel is a skyscraper covered in blinding blue flames. Rigel is so luminous that even from 860 light-years away, it beams across the galaxy like a cosmic lighthouse. If Rigel replaced the Sun, every planet up to Jupiter's orbit would be swallowed. The heat would incinerate everything in our solar system. Even Jupiter would be vaporized instantly. Rigel makes Aldebaran look dim, and makes the Sun look like a spark from a matchstick. Yet Rigel is not the brightest giant in this sequence. The next one, Deneb, defies nearly all logic. Deneb compared to Rigel. Now we arrive at a star that pushes the limits of what a star can be, Deneb. Comparison. Rigel equals 78 times the Sun. Deneb approximately equals 200 times the Sun. This means, if Rigel is a skyscraper, Deneb is a mountain glowing white-hot, dwarfing everything around it. Deneb shines with 200,000 times the Sun's brightness, 80 times the mass of the Sun, a surface so hot it glows like a needle of white fire. Here's the impossible part. Even from 2,600 light-years away, Deneb is visible to the naked eye. A flashlight seen from 2,600 light-years away. Impossible. But Deneb does it effortlessly. Rigel looks monstrous, until Deneb rises behind it like a cosmic mountain of light. But the universe grows darker, and the stars grow larger. Next comes the beating red heart of the scorpion, Antares compared to Deneb. Now we descend into the realm of swollen red supergiants. Antares, the heart of Scorpius, is a true cosmic giant. Comparison. Deneb equals 200 times the Sun. Antares equals 680 times the Sun. This means Antares is more than 3 times wider than Deneb. If Deneb is a mountain, Antares is an entire mountain range, burning red with ancient stellar fire. Place Deneb and Antares side by side. Deneb would look like a huge glowing sphere, but Antares would engulf it with its gigantic red atmosphere. If Antares replaced our Sun, its surface would extend beyond Mars. Planets would have no chance of surviving. Even Jupiter would orbit dangerously close to its fiery edge. Antares is gigantic, but the next stars make Antares look small. Now we approach the hypergiants. Cephei compared to Antares. Known as the garnet star, Cephei glows with a deep, rich ruby color. It is one of the largest red hypergiants known. Comparison. Antares equals 680 times the Sun. Mu Cephei equals 1650 times the Sun. This means Mu Cephei is more than twice as large as Antares. A swollen, dying titan shedding its outer layers into space. If Antares is a mountain range, Mu Cephei is a continent, glowing red like molten lava. Imagine, if the Sun were a small marble, Mu Cephei would be a 30-story skyscraper towering over it. But as huge as Mu Cephei is, there once existed another star that surpassed even this giant. Enter one of the largest hypergiants ever discovered. Vy Canis Majoris compared to Mu Cephei. Vy Canis Majoris is a monstrous red hypergiant whose size challenges the imagination. Comparison. Mu Cephei equals 1650 times the Sun. Vy Canis Majoris equals approximately 1950 times the Sun. It is slightly larger, but enormously more chaotic. If Mu Cephei is a continent, Vy Canis Majoris is a supercontinent, stretching into the void. Its radius is so enormous that Mercury, Venus, Earth, Mars, and the entire asteroid belt, and much of Jupiter's orbit, would all lie inside it. Its outer atmosphere slowly drifts away like red smoke from a dying bonfire. But unbelievably, even this star is not the largest we have found. One last monster remains. UY Scuti compared to Vy Canis Majoris. Now we face UY Scuti, one of the largest stars humanity has ever measured. Comparison. Vy Canis Majoris equals 1950 times the Sun. UY Scuti equals 2400 times the Sun. This means UY Scuti is about 450 times wider than Vy Canis Majoris. Nearly 2.5 times larger than Mu Cephei. Roughly 30 times larger than Antares. About 200 times larger than Rigel. Nearly 20,000 times larger than Earth. If the Sun were a grain of rice, UY Scuti would be a giant balloon the size of a sports stadium. Light, the fastest thing in the universe, would take 7 hours to travel around its surface. If placed in our solar system, its surface would stretch beyond Jupiter's orbit. Planets wouldn't just disappear, they'd be microscopic specks floating inside its fiery mass. Yet these enormous stars are nothing compared to galaxies. The Milky Way compared to stars. The Milky Way is a colossal rotating disk of 200 billion stars, 400 billion planets, nebulae, clusters, and supermassive black holes. Comparison. If UY Scuti were a single grain of dust, the Milky Way would be a continent. The entire collection of every star we compared so far, from the Sun to UY Scuti, would occupy only a tiny region inside one of the Milky Way's spiral arms. Our Sun, just a tiny pixel among billions. Yet the Milky Way is just one galaxy out of trillions. Andromeda compared to the Milky Way. Now we meet Andromeda, our galactic neighbor. Comparison. Milky Way equals 100,000 light-years. Andromeda equals 220,000 light-years. This means Andromeda is more than twice as wide. If the Milky Way is a continent, Andromeda is an entire supercontinent, stretching much farther. It holds hundreds of billions of stars, larger nebulae, a supermassive black hole even bigger than ours. But even Andromeda is modest compared to the true titans of the cosmos. IC 1101 compared to Andromeda. Now we encounter one of the largest galaxies ever discovered, IC 1101. Comparison. Andromeda equals 220,000 light-years. IC 1101 equals 6 million light-years. This galaxy is 27 times wider than Andromeda, able to fit 100 Milky Ways inside it. Home to trillions of stars. If Andromeda is a supercontinent, IC 1101 is a planet-sized landmass. Yet even IC 1101 is part of something larger. The local group compared to IC 1101. The local group, our galactic neighborhood, spans 10 million light-years. If IC 1101 is a planet, the local group is a solar system. It contains the Milky Way, Andromeda, 54 smaller galaxies. Yet the local group itself is only a tiny piece of a much larger structure. Virgo supercluster compared to the local group. Now zoom out to the Virgo supercluster. A massive collection of galaxy clusters spanning 110 million light-years. Compared to the local group, It is 11 times wider. Contains thousands of galaxies. If the local group is a solar system, the Virgo supercluster is an entire galaxy. But even this is small compared to our cosmic home. Laniakea supercluster compared to Virgo. Laniakea, meaning immense heaven, is our true cosmic address. Size: 520 million light-years across. Comparison: it is 5 times larger than the Virgo supercluster. Contains 100,000 galaxies, all flowing toward a mysterious gravitational region called the Great Attractor. If Virgo is a galaxy, Laniakea is a galactic empire. But even this empire is tiny. Because now we reach the largest known structure in the universe. Hercules Corona Borealis Great Wall compared to Laniakea. This is one of the largest structures humans have ever detected. 10 billion light-years across. Comparison: Laniakea equals 520 million light-years. The Great Wall equals 19 times larger. If Laniakea is a galactic empire, the Great Wall is an entire universe-sized continent. Light takes 10 billion years to travel across it, half the age of the universe itself. This structure is so large, it challenges the very laws of cosmology. And yet, we have only seen the observable universe. Beyond what we can see, it may be 2 times larger, 100 times larger, or truly infinite. Final message: you live on a tiny planet, orbiting a tiny star, inside a small arm of a small galaxy, inside a small cluster, inside a supercluster, inside a cosmic web beyond comprehension. But your curiosity, your imagination, your desire to explore, makes humanity far larger than its physical size. As long as we keep searching, the universe will always reveal more.